think he wants to say hello to everybody. You know, he's just going to keep his eye on you all. Right, this is the last part of the topic that we're looking at. If you have caught up with the other videos that I sent everybody or put it on Moodle, I'll go through that again if anybody needs me to. In terms of looking at question 4, which is this last topic in your exam, and this will take up approximately 50% of the marks that are going to be given to you. And what I want to do here firstly is just explain what net present value and the internal rate of return are. When we get to, and we'll hopefully be able, and we will calculate these, but just a little bit of background to it. Here what we're going to do is look at a potential investment in a project, and with that initial investment we want to see if we're going to get a return over a period of time, and if we do, we're going to invest in that project. If the return is very small or even negative, there's no point going ahead with the project. And how we assess or analyze an investment is using one of these two or both of these, the net present value and the internal rate of return. We'll look through a question and then I'll explain it further when we see some numbers. But in the exam, you will be given a formula like this, or this formula, to help you calculate the net present value. NPV is short for your net present value. That sigma there, the Greek looking E, that's the sum of. You would have seen that in the last semester. The C there is your net cash flow, which means whatever inflows and outflows you have, you just net them out and you have your cash flow or money coming in. The R there is your discount rate, and that again tells you how much you have to reduce your future investments to a present value. Again, I might explain that later on, but just take out that we have a type of interest rate here that we're going to be using. T is the year that we're going to be making the investments in. So say, for example, if you have an investment period for 5 or 6 years, T is going to be representing 1 when you're talking about year 1, and all the way up to say 5 if you're talking about year 5. This will only make sense once we see a question, by the way. And let's ignore that C naught for a moment at the end there, but the C again just represents your net cash flow. So that formula is going to be given to you. We'll see it again soon when we look at the question. Here's a typical exam question for you. Okay, I don't know what year this is coming from, but this is featured before, and I'm going to do 2 calculations for you just to get us through understanding what we're going to do here. But you're going to have a look at a project that's going to last for a 6-year period. We also see a year 0 there, which is today, or your initial investment, and we're given these inflows and outflows. Okay, I won't go through the numbers, but you can see the numbers there. Well, if you recall with the formula, just going back, you have your C there, your net cash flow. So the net cash flow here is just your inflows minus your outflows. Okay, so we're going to have to do a calculation breaking up that formula. Also, given in the question here, you're told that the firm wants to earn at least 12% per annum. We're going to take that to be your discount rate, or the value that's in your formula. So calculate net present value and comment. Right, just don't take all of this at once, the table. So I just kind of redone up the table. Firstly, it was horizontal. If you recall, the end of year 0 to 6, inflows and outflows for each of those years. So I just kind of transposed the table so that we have it looking like this here. I think it's easier to work with. So you have your inflows and outflows. Your net, or your net cash flow, is in blue. So it's your inflow minus the outflow. You have a -70. You can do the calculations as you go through there. And this is going to be representing C in your formula, your net cash flow. In red, the 1 plus R to the power of T, that is your other part of the equation. Again, I'm just going to jump back to show you where that is. If you see there, 1 plus R to the power of T, so I'm breaking the formula down. I have your net cash flow, which I just calculated. The 1 plus R to the power of T is my next calculation. And we are told that the value of ore, or the discount rate, is 12%. We're going to take it that year 0 is always going to be 1.0. Okay. If you put 12% or 0.12 in for ore in that heading there, 1 plus ore, which is 1.12 to the power of time. Anything to the power of time there, you see the years 0 to 6, you're going to put 0 to 6 for each row as you're going through that calculation. So say, for example, in year 0, you have 1.12 to the power of 0, and anything to the power of 0 is equal to 1. That's why we have 1.0 there for year 0. In year 1, in red again, you have 1.12 to the power of 1, and that gives us your 1.12. And you keep on doing that, 1.12 to the power of 2, 1.12 to the power of 3, all the way down to the last year, 1.12 to the power of 6, and you will have those values that you've just calculated there. If you're just not used to using the power button in your calculator, just have 1.12. If you have your calculator handy there, just put in 1.12, multiply it by 1.12, and you'll see you'll get 1.2544. And if you keep on multiplying the new answer by 1.12, you'll get those numbers that I have just there in red all the way to 1.9738. But that last column has present value, and it's your net cash flow divided by 1 plus ore to the power of time. How do I know that? Well, if I go back to the formula, you have your net cash flow CT divided by 1 plus ore to the power of time. And that's what we're going to do here. That minus C0 is your initial cash flow, which is your negative 70,000. And if we divided that by 1, you get to 70,000 anyway, if you look here. So the 70,000, negative 70 divided by 1 is going to give you your negative 70. Every other number that's in blue is divided by the red number, and it's going to give you the corresponding values that I have in the last column. Okay, all we're doing here are looking at projected cash flows in the future, years 1 to 6, and we're discounting them back to the present value. So that 20,000 would be the equivalent of 10,000 today. Okay, and what we need to do then finally is, if you remember that Greek E letter, the sum of, we need to sum up that last column, and that will give us a total present value, or what we call a net present value of, in this case, it happens to be a negative 2,070 or negative 2.07. Okay, remember these are all maybe in thousands of euro. So this is a negative 2,070. Should we go ahead with this project? The answer would be no, because it gives you a negative value. Okay, so that's essentially what you're being asked to do in that first part. Get the net present value and comment on whether the firm should actually go ahead with the project or not. And we just recommend that they shouldn't. And the reason why they shouldn't mostly is because the inflows aren't as high as we might have expected, or the discount rate of 12% is too high, and we might require a lower discount rate. And just as a side note, a discount rate is made up of a number of factors, including the interest rate if you have to borrow for this project. It might include inflationary pressures. It also might include some risks like geopolitical risks, or risks to your industry, or maybe the product that you're producing here, maybe it'll just die off after a couple of years. So the higher the risks involved, the higher the interest rate, the higher the inflation, that discount rate will get higher even more. Okay, so we would rather a lower discount rate reflecting the lower risks involved and going ahead with this project. But even at that 12%, we still end up with a negative value, and we shouldn't go ahead with the project. So the project's not earning the required percentage, firms should not proceed with the investment. Right. The next part was, ignore that diagram for the moment, but the next question given is, if the net present value of the project at 10% per year is 2.68 or 2,680 euro, estimate the IRR graphically and comment on its meaning. Let me tell you what the internal rate of return is. When you calculate an internal rate of return, it's going to be based on a percentage, and it's going to be reflecting a percentage like the discount rate. The discount rate will give you either a negative net present value, or it could give you a positive net present value. You'll see in our previous, if you saw in your previous example, the net present value of 12% gave us a negative 2,070 euro. Look at this question here. We're told that if the rate happens to be 10%, it actually flips that from a negative net present value to a positive. So you see the risks have been reduced with that lower rate of 10%. And now we have a positive net present value of 2,680. So what's the IRR? If you the word internal is a clue. Internal just means that in between the two net present values that we have, one is negative, one is positive, we should get a discount rate that would give us a net present value equal to 0. Okay, so the IRR, if anyone wants to note that, it's probably in your notes anyway on Moodle, but the IRR will give you a discount rate when the net present value is 0. Okay, so can anyone even, I know you might be, you can see the screen there, unfortunately, I couldn't hide it up from you, but if you think about this, right, 12% discount rate gave us 2,070 euro negative. A 10% discount rate gave us a 2,680 positive. So a 0 net present value is almost halfway between that negative and positive value. Therefore, the IRR, or the internal rate, should be halfway between the 10 and the 12%, which is approximately 11%. You're asked here to solve or estimate it graphically. Okay. You don't have to be as accurate with this in terms of scaling. So just do your positive and negative y-axis. I've just plotted in 10 and 12. You don't, again, have to scale it from 0 all the way up to 12. Don't bother doing that. Just ignore the earlier part. Put in 10 and 12 somewhere. At 10%, you plot what the net present value figure is. And where we're told in this part 2 question, if you just look up at the question there, at 10% you have a positive 2.68. So at 10% and 2.68, you can't see a coordinate there. But I'll put this up as a video and I'll highlight them again. But if you were imagining, if you can visualize a coordinate or a point that connects to 10 and to 2.68, it would pretty much be at the beginning of that straight line. Okay. Likewise, we had in the previous example, we calculated at 12%, we had a negative 2.07. So if you can visualize again a coordinate or a point that connects to 12 and a minus 2.07, which would be at the end of that line, and connect the line with connect those 2 points with a straight line, and what you're looking for is the where the line intersects that x-axis, and that gives us a net present value equal to 0. When the net present value is 0, your internal rate of return is approximately 11% where that intersection occurs. Okay. What I'll do is move on, because you will either be asked to solve the internal rate of return graphically, or you will be asked to solve it using a formula. Even, I can't recall where this question came from, what paper it came from, but I'm going to solve this using the formula. You will either be asked to solve the internal rate of return graphically or using a formula, one or the other. Don't do both of them. If it's a calculation using the formula, this is the formula that's given to you in the exam. And you see NPV1 and NPV2 are those two values that you were either calculated in part 1 or was given to you in part 2 to the question. If you recall, NPV1 was, I think it was negative 2,070. And you were told in part 2 that the NPV value, if you recall there, look at the NPV value was a positive 2,680 or 2.68. So we're going to plug those values in where you see NPV1 and NPV2. And I1 and I2, I don't know why in the formula they call it I, but this is the same as the OR1 and OR2 that we were given. Again, going back to the previous question, you see there, we were told that the value of the project, the discount rate was 10%. And I won't go back to part 1, but part 1 we were told it was 12%. So I2 is going to be 10% and I1 is going to be 12%. Note the negative here in the formula on both the numerator and the denominator. Make sure you take that into account, because sometimes the net present value, the second one there, is going to be positive or negative, one or the other. So you have to treat that with your basic mathematical rule. A minus times a plus is a minus, and a minus times a minus is going to give you a plus. But we'll worry about that when we see it in the next scenario. Here's the summary of your values that we either calculated or were given to us. So NPV1 is that, and I1 or OR1 was your 12, and your next part 2,680 and 10%. And we just plug them into the formula as given. Okay, you can leave it as a percentage or change it as a point to a 0.12 or a 0.1. Okay, and you'll notice there I leave in the positive sign when the net present value is positive, and I leave in a negative sign, obviously, when the net present value is negative. So again, just breaking that down, negative 2070 by 0.1 or 10% is going to give us your negative 207. Likewise, with the right side of that numerator, 2680 by 0.12 is going to give us your negative 321.6 minus by a plus is a minus. And below that then we have, notice, negative 2070 minus plus 2680. So minus times a plus is your negative. So make sure you add those together, okay? Some people in the exam tend to forget that. They just write down minus 2070 plus your 2680 and they have a low number there, like 610. So make sure the minus by a plus is a minus and you add those together, giving you a negative 4750. Working through that then, you'll end up with a 0.1113 by 100% will give us your 11.13%. And if you recall back on your diagram, that looked very much like what we estimated on your graph.